In this video, we discuss an overview of methods. In Java, we accomplish tasks or actions through methods. A method defines a specific task or action. Methods are declared within a class. Methods can help us avoid duplicating or repeating code by writing the code once as a method that can then be invoked whenever needed. To declare or define a method, we start by specifying the method header. The method header includes the method's visibility, return type, name, and formal parameters. The method header might also include the keyword static if it's a static method. Static methods will be covered elsewhere. After the method header, the method body is enclosed in curly brackets. Think carefully when defining your method header. Consider what inputs are needed to accomplish the task and what data, if any, will be output. Use descriptive names for the method itself and for the formal parameters. This is an example of a method. The method header is public, static, int, add, and there are two formal parameters, int n1 and int n2. Here are the brackets that surround the method body. Let's look at each component of a method header. A method's visibility specifies from where that method can be seen and accessed. Methods can be public, private, protected, or what is known as the default visibility, which is declared by omitting a visibility keyword. For now, we'll focus on public methods. Public methods can be accessed from any class. Method names should use lower camel case without underscores and should be descriptive of the task. Method names will often contain verbs since methods are how we do things. Our example method is public, and the name follows naming conventions, and is descriptive because the task or action performed by this method is to add numbers together. The formal parameters are the inputs to the method. This is the information the method needs to take in order to accomplish a task. Formal parameters are local only to that method, and they exist only as long as the method is running. When the method ends, the formal parameters are released for garbage collection. Formal parameters should follow the same naming conventions as variables, lower camel case without underscores, and descriptive of the information they contain. Our example method has two formal parameters, both of type int, n1 and n2. We can use n1 and n2 inside the method, but they cannot be accessed outside of the method, and they will be released for garbage collection when the method ends. If a method completes its task and doesn't return any information out of the method, it is called a void method, and we use void as the method's return type in the method header. Some methods send out or return a value when they complete, and these are called valued methods. A valued method will return a specific type of information. That type is defined in the method header as the return type. The return type can be a primitive or an object. Inside of a valued method, there will be one or more return statements that returns a value of that type. Note that there must be a return statement in every possible branch within the method. Be mindful of this when returning from inside of loops or conditionals. Our example method has a return type of int and one return statement that returns an integer value. Declaring a method specifies what the method will do. Invoking a method makes the method run. Java executes statements in order, line by line, unless something changes that. For example, conditionals and loops can cause statements to be skipped or repeated. When a method is invoked, that also changes. The program execution changes by jumping to that new method. Note that you will often need an invoking object to invoke a method and make it run. Java has what is called the runtime stack. The stack holds what is called activation records. An activation record contains information about one specific method call, including the formal parameters and the local variables, which are variables declared inside of the method. Each method call gets its own activation record. So, for example, if you called a method twice, there will be two activation records created. Java will execute the method that's at the top of the stack. This example stack shows two methods. Currently, method B is at the top of the stack, so Java will execute method B. When you invoke another method, an activation record is created for that method. In this example, we have just invoked method Q, and so that activation record is created. That record is then pushed onto the top of the stack. The original method is paused, and control jumps to the newly invoked method, and we start executing that method. In this example, method B is paused, and we start executing method Q. When a method ends, either by reaching a return statement for a valued method or by reaching the end of the method for a void method, that activation record is popped or removed from the stack. The formal parameters and local variables from that method invocation are released for garbage collection. Control then returns to the method that was paused before, which is now again on the top of the stack. We pick up where we left off in that method and continue on. This is how the runtime stack works for method invocations. Void methods can only be invoked as their own statement. You cannot invoke a void method inside of another method or use it as the value for a variable. When you invoke a valued method, you usually want to do something with that returned value. You can store it in a variable, print it, or pass it to another method. The method invocation itself can be used anywhere you would use a variable of that method's return type. For example, our add method returns type int. So we can use a call to our add method as the int value and assign that returned value to a variable. We could also use it as a parameter, the method invocation as a parameter that we pass to some other method that requires an int parameter. If a method has formal parameters, then when you invoke the method, you have to send that required data into the method. Actual parameters, or arguments, are the values passed in when you invoke the method. You can pass in values or variables of the specific type. The actual parameters have to match the formal parameters in type and order. In our example here, when we invoke the add method, we pass in the actual parameters of the value 3 and the variable num, both are which of type int as required. Java is passed by value. This means that the value of the actual parameter or argument is passed into the method. The value of a primitive is just the data itself, so that's what gets passed. But remember that the value of an object reference is a memory location, so that memory location is what is passed into the method. This means that changes made to an object inside of a method will affect the object outside of the method because it's the same object. We'll talk more about this idea elsewhere. The main method is a special method that has this exact method header, public, static, void, main, with one formal parameter of type string array. The main method is the one that runs when you run your program. You don't call main, it's called behind the scenes by the Java Virtual Machine. One last note about what you can do with methods. Method overloading allows you to write multiple methods with the same name but different formal parameters. This can be very useful if multiple methods accomplish the same task but use different inputs. Overloaded methods have the same name but must have different parameters in type, number, or order. Overloaded methods can have the same or different return types. This was a brief overview of methods in Java. Methods are how we accomplish tasks. Think carefully about how you define and use methods to reduce duplicated code and create code that is readable, flexible, and maintainable. Make sure there's always a method to your madness. Happy coding!